Now I will move to the next problem, and in this particular problem we are interested in the calculation of the current. We are interested in the calculation of the current in 5 ohm resistance using this theorem. Again, the steps are similar. First step is remove the load resistance, short circuit the output terminal, calculate its current in the short circuit. Second step is for the calculation of Rn, we have to find out its VOC because dependent source is there. In that case, this should be removed and we are able to we have to calculate its voltage across this terminal. Means indirectly we have to find out VOC and ISC. Means indirectly we have to find out VTH and IN, that is Norton's current. So first what we will do, we will remove the load resistance and we will short this output terminals and we will calculate first the Norton's current. I will write the same. For calculation of, do it fast. For calculation of IN, load resistance is removed and output terminals are shorted. Yes. Draw this figure. In that case, the figure will be something like this. This figure will be something like this. Hello. In this case, this is 3. It will be the A point, this is B point. This is A, this is B. And this will be the short. This is right. This is 3 ohm. It will be 2 amperes. This is 2 ohm. It is 10 ohm. This is plus and minus. This is 10 into IA. Is it right? Now, this current is IA1. This current is IA. Is it right? With this load. I have shorted, means I will give some different name to this. It is IA1, then this will be the IA1. Now, our aim is the calculation of current in the short circuit. Now look at the number of methods I am discussing. Every problem has many number of methods. You can use any one of them to solve this particular case. We are interested in current in this branch, which is IN. This is short circuit. That's why I recommend we should not use nodal analysis. Is it right? This is branch, this is loop 1, this is loop 2, this is loop 3. We are not able to apply the KVL to this loop or this loop, use the super mesh. Apply the KVL, you will get one equation, second equation from this current source branch, and third equation from this loop. Otherwise, this short circuit is completely parallel to this branch. Find out its parallel combination because we are not interested in the current in this branch. इस branch में हमारा current का interest नहीं. अगर होता तो हम इस parallel combination को नहीं लेते. Are you getting me? Here we are interested in the calculation of current in this branch, and whenever short circuit is a parallel to any branch, all current is flowing through this particular short circuit. The current flowing through this branch will be 0. That's why I am taking its parallel combination to simplify the figure. इसका मतलब ये नहीं कि हमें हर बार सिंप्लीफाई करना पड़ेगा. अगर आपको लगता है कि ये सुपर मैश एक लूप होगा, ये दूसरा करंट सोर्स ब्रांच होगा, and I will apply the KVL to this, that is also fine, and you are able to get the same answer which I am getting the answer from reducing this figure. I am reducing this figure. This will be the new figure. This will be the new figure, which is, I am taking its parallel combination, nothing else. No more complications I am adding. Just this is the short circuit. This is plus minus, this is 10 into IA1. This is the upward direction current, which is the 2 amperes. This is 2 ohm, and this current is the IA1. This is IA1 and it is the 10 volt. Now The figure is very simple. Is it right? Now here, in this case, we are interested in this current, which is IN. I will give the name of this current, which is IN. The name of this loop current is IA1. Now we are not able to apply the KVL to this loop or this loop. Use the super mesh. This is only one mesh. From that we will get equation number 1, and then we will get the second equation from this current source branch. What are the first applying the KVL to super mesh? Applying KVL to super mesh. We are applying the KVL to the super mesh. If we are applying the KVL to the super mesh, first mark the polarity. This is plus minus. We have taken this current clockwise. That's why it will be plus minus. Already these remaining terminals are available. I will start from this point. I'm traveling in the clockwise direction, negative to positive, plus. It is plus 10. Then I'm moving forward, positive to negative, it is a minus. Its potential is 10 into IA1. Then we are coming back. Positive to negative, which is minus. Its resistance is 2 and its current is IA1. Current is IA1, which is equal to 0. This here, in this case, this 10 is equal to 10 plus 2, that is 12. 12 IA1. I am shifting this value to the next side, and we are able to find out this value of IA1 directly. This IA1 is equal to 10 divided by 12. How much is the value?
0.83.
0.83 amperes. 0.83 amperes is the value of the current which we are getting through this particular way. So here, if we know this value, then we have to take another equation from the current source branch. We get what we get from the current source branch. This is upward. Which current is upward out of these two? That will be taken as a positive. This 2 is equal to IN, and this is downward. That's why it is a minus IA1. Is it right? We are interested, IA1 already we have calculated. We are interested in the IN. Therefore, this IN is equal to 2 plus IA1, which is equal to 2 plus this IA1 is 0.83 amperes. This IN is 2.83 amperes is the value of the Norton's current. Always we have to take its modulus value, that is positive value. Is it right? So here in this case we have calculated the value of the Norton's current, which is this 0.83 amperes is the Norton's current. Now we have to find out the Norton's resistance. And for the calculation of the Norton's resistance, we have to use a similar method, which is VOC upon ISC. Is it right? I will write here. For the calculation of IN, we will use formula. Which formula? This Rn is equal to VOC upon ISC, which is very same as VTH upon IN. Is it right? Now we will find out this VTH or VOC. For that, what we have to use? We have to remove this load resistance and we have to keep its terminal open, and then we have to work out on the calculation, and then we are able to find out its value. I will use the similar figure. Now here in this case, if we are interested in the calculation of that value, I will start here. For the calculation of VOC, we will remove load resistance and we will redraw the same circuit. We will redraw the same circuit. We will remove the load resistance and we will redraw the same circuit. Is it right? If we are doing that, how will be the figure? I will draw here. This is A point, this is B point. Here it is 3 ohm. This is plus minus 10 into IA. Is it right? This current is the 2 amperes, which is upward. Here, this current is the IA. It is 2 ohm. This is 10 volt. This IA with the load, and when the load is shorted, we have given its name as the IA1. Now here, I will give its name as IA2. This will be IA2. This will be the IA2. Now we will work out on this calculations. Now, apply the KVL to the loop 1 and loop 2 and prepare its equations. Yes, I will be back in within a Now here in this case, I will assume the two separate currents. This current will be IA2, right? And this current, in this case, this current, I will give some different name. I will give some different name. Maybe IA. Maybe some different name. Maybe IX, because IA is already name is available. IX, some different name. Now we have the two loops and two equations, and we are interested in the calculation of voltage, means we are interested in this current in this branch, which is IX. Now mark the polarities. This will be plus minus. Here it is a plus and minus. In this case, this will be the plus and minus. Now apply the KVL to the loop 1, loop 2, or any other method and calculate its value. Here we can use the nodal analysis method also. This is node 1, this is node 2, this is one branch, second branch, and third branch. And any of the branch don't have the zero resistance path. That's why we can use that method also. But still, I'm using here the mesh analysis. In this case, we are not able to apply the KVL to the loop 1, KVL to the loop 2. I will take this as a super mesh, and we will apply the KVL to the super mesh, and we will start from this point. I will write here, applying KVL to super mesh. We get. आपको ये assume नहीं करना है कि मैं हर बार KVL क्यों use करूँ. You can use the nodal also, because I have to choose some of the methods, one method. That's why I'm choosing any one. That is super mesh in this case. We are starting from this point. Negative to positive, plus 10. Then positive to negative, it is minus. It is 10 into IA2. This is 10 into IA2. Then positive to negative, that is minus 3 into IA2. Sorry, 3 into IX. This is 3 into IX, because its current is IX. This is source. That's why positive negative 10 into IA2. That's why we are coming back. Positive to negative, that is minus 2 into its current, and its current is IA2, which is equal to 0. This is the application of KVL. Now, how is the equation? This is 10 IA2 minus 10 IA2, 2 IA2, means minus 12 IA2. Minus 12 IA2, then minus 3 IX, which is equal to, I'm shifting this value to the next side, that will become minus 10. Is it right? This equation will be 12 IA2 plus 3 IX, is it right? Plus 3 IX, which is equal to 10, and this is the equation number 4. Is it right? Now here in this case we have the equation number 3. Now we will find out another equation. We need another equation. We have to find out another equation. Is it right? How will be the next equation? We will get from the current source branch. From current source branch. We get. What we will get from the current source branch? This 2 amperes is upward, means this 2 is equal to, which current is upward? IX minus IA2. This is IX minus IA2. If I'm writing this equation in the proper way, IA2, IX and constant, means it is a minus IA2 plus Ix, which is equal to 2. This is the equation number 4. Is it right? Now, in this case, we have the two equations and the two unknowns, and the unknowns are Ia2 and Ix. But here, we are interested in Ix because we want to find out this open circuit voltage. Current in this branch is our interest. Is it right? That's why find out these two values and tell me the answers. What is the Ia2 and what is the value of Ix? Anyone from your side? Yes, Saurabh.
Ia2 is equal to 0.26.
Ia2 is 0.26 amperes.
Ix is equal to 2.26.
Again,
Yes.
2.26 amperes. Now, if we know these values, we will find out the VOC, which is equal to VTH, which is equal to, we are traveling from the V towards E. We are traveling from negative to positive, that is a plus. It is modulus value plus 3 into Ix. And Ix is 2.26. Work out this value and find out the VOC. Yes, anyone?
6.78.
6.78 volt is the value of VOC. If we know the VOC, then I will use a formula. This Rn is equal to VOC upon ISC, which is VTH divided by IN, which is equal to VOC is a 6.78. 6.78 divided by IN. IN already we have calculated, or ISC already we have calculated. How much is the value? It is 2.83. Is it right? It is 2.83. This value is 2.83. Work out this calculation and find out the Rn. That is Norton's equivalent resistance. Yes.
2.39.
2.39
39.
ohm is the value of Rn. Yes. Now, if we know the IN and Rn, if we know IN and Rn, then complicated network is replaced by Norton's equivalent network. Norton's equivalent network. How will be the figure? Something like this. This is the Norton's equivalent network. Reconnect load resistance, which is removed in the first step. This is RL, which is equal to, here this Rn is 2.39. This is 2.39 ohm. And how much is the ISC, which is 2.83? This is the 2.83. This is 2.83 amperes. And now, how much is RL? I will go back. Calculate the current in 5 ohm resistance, which is this. We are interested in the calculation of the current in 5. That's why we have removed the 5 ohm resistance. That's why RL will be the 5 ohm. This is 5 ohm is the RL. Now, use the formula. How is the formula? This IL is equal to IN into Rn. IN is 2.83 into Rn 2.39 divided by Rn plus RL. 2.39 plus RL is the 5, which is equal to, find out its current. Yes, anyone, unmute yourself and tell me the answer.
0.9.
91.
0.91 amperes is the value of the load current. 0.91 amperes is the current flowing through the load resistance using this particular method for this theorem, which is the Norton theorem. Is it right?